Hello everyone, I'm CodeMath, and in today's video we are going to talk about sets of numbers. So we'll cover an introduction, sets, operation, and number sets. So starting off with sets. A set is a collection of objects. You can think of it like a bag containing apples. They are noted with brackets and items are separated by commas. If we take a set A containing all the numbers from 1 to 5, we'll get this. A good way to understand mathematics is to take a visual perspective. For example, let's look at two sets A and B visualized with circles. We can also perform manipulation with these sets. This is called an operation. An operation is a relation between two entities that produce a new entity. Here are some operations we can apply to sets. We have the union, and it is used to merge the two sets together. Like we can see down below with these circles A and B, and they are getting linked together. In a mathematical perspective, it is written with the set A and B, and you make A cup B is equal to all the objects in A and B. So to see if you understood correctly, try to answer that question. The union of A and B is the set of all elements in A and B. We also have the intersection, and it is used to know what objects in common have two sets. For example, two circles A and B have in common the intersection as they are overlapping each other. It is denoted like this, and the result of that intersection is all the digits A and B have in common, so 3, 4, 5, and 6. Again, you can test yourself. If we have A equal to 1, 2, 3, 4, 5, 6, and B equal to 3, 4, 5, 6, 7, and 8, then what is the intersection of A and B? As we know, the intersection of A and B is the set of all elements that are both in A and B. So, it will get us to 3, 4, 5, and 6. There is also the slash, and it is used to suppress element in a set, like this. You take a circle, and then you take off a part of it. It is actually the same thing with sets. If we have a set, so if we got a set A and B, if I decide to do A slash B, it will mean to take off from A all the elements that are in B. So it will give us only 1, 2, and 3. We also have the equality, and it is used to compare two sets that are alike. So right here we denote the equality between the circle A and B. So if we have A containing 1, 2, 3, 4, 5, and 6, and B has the same elements, can we say that A is equal to B? Of course, yes. It is important to also talk about subsets. It's like a smaller set inside a bigger set. Notice how the inner circle is like a subset to the outer circle. Now, if we have A containing all the digits from 1 to 6 and B containing all the digits from 1 to 8, then what is A subset of B? Actually, this time there is nothing to change since the notation is already done in the question. So as we finish with operation, let's get into the most important subject of that video. Number sets. We are going to apply that notion of set to numbers. They are classified within these circles, R, Q, D, Z, and N. The smallest circle represents the natural set. The natural set contains all the positive integers, like 1, 2, 3, 4, 5, 6, until infinity. We could put all these numbers on a line to get an idea of how they organize. So I made an axis starting off with 0 and ending with infinity. These sets contain some interesting numbers such as prime numbers, but I'll cover these in a later video. So now we got our sets, but this time we covered the n set. Notice how the z set also takes the n set. The z set contains all the positive and negative integers. So I again drew an axis, but this time both sides goes on to infinity. By the way, I would like to add that I purposefully removed the C set because it was too complex to talk about it. As we are going into the set that contains all decimal numbers, I think it is important to describe what decimals are. They are numbers with commas and describes the smaller bits of number. They can be infinite, but they always have a periodic sequence of digits, like shown down below on this axis. This time, the axis goes on to infinity with both sides, but also in a third way. As you're getting the hang of it, we are now going to talk about the Q set that contains all the rational numbers. Rational numbers are numbers that can be written as a fraction. They are sometimes infinite and they have a periodic sequence of digits if they produce a decimal number. And now, at last, but not at least, we have the biggest set possible, the real set. The real set is the union of all the sets we saw previously, but with irrationals added. Irrationals are infinite and have a chaotic sequence of digits. You probably know one of them because pi, the most popular number, is an irrational number. Numbers are an abstract representation of quantity, and we can look for their relation with other numbers. Through addition, we can add numbers with each other like this. 2 plus 3 is equal to 5. It is important to say that addition is commutative. This means that if I switch 2 and 3 to 3 and 2, I will always get the same result, 5. We can repeat addition through multiplication like this. If I make 2 times 3, I will get 6. But this multiplication is the same as if I make this addition 3 plus 3, or even 2 plus 2 plus 2. In both cases, I will always get 6. We can also note the fact that multiplication is commutative. Now, we can also repeat multiplication through exponentiation like this. 2 raised to the third power is equal to 2 times 2 times 2, which gives us 8. We can also reverse these operations. Like, we can take off a quantity to a number with subtraction. For example, 3 minus 2 is equal to 1. But with the same principle, we can repeat a subtraction with division. 3 divided by 2 will give us 1.5. And if you do 1.5 times 2, you'll get 3. So here's the end of the video. I hope you enjoyed it, and I'll see you next time.